Welcome to our dawn. In this video lecture series, this is the second part of a complex number series. So, in this video, what we do is we do first polar representation of complex number. By polar representation, what I mean is that it complex number in form of any angle. Second, which we are going to discuss is de Moivre's theorem. De Moivre's theorem. So next, third thing which we're gonna discuss is roots of complex number. And fourth and the last topic of the day is Euler's formula. So, starting with the very first topic of the video, let us discuss polar representation of complex number. So for polar representation, first of all, we draw a graph which consists of imaginary axis and real axis. So the perpendicular axis, we take it as imaginary axis, on which imaginary part is mentioned, and next the horizontal axis, which we taken as real axis, on which real part is mentioned. Let a complex number denoted by a plus iota b, or you can say that x and plus iota y, in which ab or xy is real part. So a and iota b, how it is represent? A on real part, b point on imaginary part, and theta is angle between them. Suppose, what is theta? So first of all, we have to know angle between the real axis and the axis joining the origin axis and the axis joining the origin and complex number point. The point which, or you can say the point which denote the complex number. Let the x is equals to r cos theta, where r is the length of the axis which is joining the origin and a complex number. So y is equal to r sin theta. So r is equals to x square. If we take a square of first and second and addition, so r is equal to square root x square plus y square, which is equals to the absolute value of a complex number. Here one thing which I want to mention is that coordinates are written a and b is equals to a is equals to x and b is equals to y. So z is equal to x plus iota y. So r cos theta plus iota r sin theta. So what we can do is here on simplification, the complex number is equal to r cos theta plus iota sin theta. So here r cos theta plus iota sin theta represents the polar equation of z, and r and theta are known as polar coordinates, which is known as polar coordinates. And the form z is equals to r cos theta plus iota sin theta, which is mentioned in on the screen, is known as polar representation. So next topic, we study de Moivre's theorem. So for de Moivre's theorem, what we have to assume, z1 is equals to x1 plus iota y1 and z2 is equals to x2 plus iota y2. So now what we do is we mention it in polar form, that is r1 cos theta 1 plus iota sin theta 1. Similarly, mentioning z2 in polar form, r2 cos theta 2 plus iota sin theta 2. So it will become z1 is z2. If we both multiply equation, then it will become r1 r2 cos theta 1 plus cos theta 2 plus iota sin theta 1 plus theta 2. So this is the equation when we multiply z1 and z2. Now when we divide z1 and z2, what we obtain is r1 divided by r2 cos theta 1. First of all, cos theta 1 minus cos theta 2 plus iota sin theta 1 plus theta 2. Theta iota sin plus iota sine theta 1 minus theta 2. So if we take the n numbers and if we take the n values, if z1 is equal to z2 is equal to zn, so what it becomes is, if we take a z raised to power n, it becomes r cos theta plus iota sin theta raised to power n. So where zn is equal to r cos n theta plus iota n theta, which is known as de Moivre's theorem. So this is the form of de Moivre's theorem. Going to the next part, we will discuss roots of complex numbers. So for finding roots, let put the value of n as 1 by n in de Moivre's theorem. De Moivre's theorem form which we just read, which is, just substitute the value 1 by n in case of n in de Moivre's theorem. So cos theta plus 2 pi k by n plus iota sin theta 2 pi k by n becomes the root of theta 1 plus 2 pi k upon n, become the root of complex number. By this formula we can find root of, which is Euler's formula, So for Euler's formula, what we need to do is that e raised to power iota theta, that is exponential raised to power iota theta, is equals to cos theta plus iota sin theta, where x is equals to iota theta. We do the power e raised to power x. Similarly, here we put e is equals to iota theta. So this formula is known as Euler's formula. Now if we take a number e raised to power a complex number z, then it becomes ex plus iota y. Then ex into, we know about the it becomes addition multiplication of the base. So e raised to power x into e raised to power y. So it becomes e raised to power x cos y plus iota sin y. So this is the third part of a complex numbers, second part of a complex number series. I hope you will like it.